Hi everyone, so today we're going to have a look at the first year exam content for CAD CAM. So what you need to know for the exam are first of all what the terms CAD and CAM actually stand for, how they're being used more and more in industry, what the different kinds of CAM machines there are, what the term computational fluid dynamics means, what finite element analysis means, what rapid prototyping means, what electronic point of sale is, and then what production planning and control networking is. Now, CAD/CAM is probably a topic, if you've done this at GCSE, I'm sure you've heard of both those words before. Now it's more about taking that information and showing how is it applied to industry practice and how is it actually used on a day-to-day basis. So first of all, we just go over the advantages and disadvantages. So advantages of CAD/CAM are obviously it speeds up the design and development process, because what you can do is you can edit your drawings as you're going along. So hopefully now you've downloaded Fusion 360 and see the advantage is once you've got your initial concept on the screen, if there are changes that need to be made, it's quite easy to take that design and edit it rather than having to redraw it by hand over and over and over again, and it's easier to share it with other people as well. So that then links to the next point where it makes it easier for different designers to work together from different locations. So now because you can share your files with other people, there's nothing stopping you from working and designing with someone from America or China or wherever it may be, because it's all done cloud-based. It's really easy to share work. Whereas in the past it used to be you'd sketch on paper, you don't have to have that posted, that'll take a few days or weeks wherever it's going to get to where it needs to go, and it'll just be a big faff. And then it can be quite easy to set up CAD machinery as well. So once you've got your CAD design, it's then quite easy to set up the CAD machinery that goes with it. So then there's not a lot of waiting and setting up time. Once you've got it ready to go, it's pretty much ready to plug in and go. And the more modern the machines are, the easier they are to set up. So disadvantages are, it does have a high setup cost. So obviously, as an education establishment, we get Fusion 360 for free, and then US students get it for free as well. But the software itself can be quite expensive depending on what the software you're getting. Obviously there are things like SolidWorks, Adobe Photoshop and all this sort of things, and those all can run up quite a high cost. But on top of that, you've also got the machinery, which is really expensive. So you think about the CNC router that we have in the workshop, that can go for about £15,000-20,000. Standard sized laser cutter, you're looking like 8,000-9,000. So these are machines that are quite expensive. On top of that, you've then got to train the people on it. So then you have to pay for someone to come in, consult, give training to members of staff, and that again, you're paying people that are well trained in these areas can charge quite a lot of money for their skill set. So if you are someone that ends up becoming a very capable CAD technician, if someone wants to pay you to come in, you can charge quite a lot of money for a day to go somewhere and show their staff how to use it. Software has to be updated regularly. Now some software will update it for free once you've got it, but then say for example the yearly subscription, you have to pay for like a set fee every year, and sometimes those can cost quite a bit of money as well. And then the main disadvantage in terms of like designing is that you can't just sort of sit down quickly and get a quick sketch out. So obviously if you're just working paper and pencil or sketchbook, if you've got a quick idea, you can just jot down an idea quickly and then develop it later. Whereas if say you've got a big idea in your head and you're like trying to get it down quickly, and then you've got to turn your computer on, taking forever to load, and then you've got to open the software, and then by the time you've done all that, your idea sort of disappeared, you kind of lost the momentum. And what you've got down at the bottom here in red, now it's really important you never do this, is there's a tendency sometimes people say, oh, the reason CAD/CAM is bad is because people will lose their jobs because machines will take over. And that isn't the case. What we're doing, or what CAD/CAM is doing, sorry, is just developing or creating different jobs. Because now, as I said, CAD technicians, machinists, all these are very, very highly skilled specialist jobs. So rather than, okay, there may be less unskilled jobs where people are working on production lines, but there's a different skill set now required that does still have a different workforce. So it's not replacing people, it's just changing the kind of people needed. So those are the sort of the generic advantages, disadvantages. So we're going to have a look at some of the processes before. Now, some of these you'll have seen before, some of them might be relatively new to you. So first one being laser cutter. Now most people are familiar with laser cutters now, maybe not so much about how it works. But essentially what you have is you have your high energy laser beam. So in our laser cutter, we've got our CO2 laser at the very, very back of it. So what will happen is a beam comes out and then it reflects off a mirror, and there's about I think 6 mirrors in our laser cutter, depending on how far it has to travel. So the laser beam will shine, it is reflected off the mirror, goes through a focusing lens, ignites with gas inlet, and then that, once it's gone through our focus beam, that creates your cutting beam. So what happens was, this is why you need to have extraction on the laser cutter as well. So when you turn it on and you hear that sound, is because it creates smoke, you need to extract all of that gas out, because depending on what the material is, it can be quite toxic or like bad for you, not necessarily toxic. There's some materials that are toxic, like PVC, which has chlorine in it, which is why you can't laser cut it. But it is very, very effective, and a big benefit to laser cutting is the line that it cuts is very thin. So there's sometimes when you're cutting, if you think like the thickness of a bandsaw blade or a circular saw blade or a tenon saw blade, that is a couple of mil thick, so you have to factor that in when you're making your product or whatever it is you're doing. But the laser cutter, the laser line is very, very thin, so it can be highly accurate. So for the most part, you'll do it on 2D design, on a 2D CAD software. So for typically in schools and colleges, it's TechSoft 2D Design. There are other ones you can use as well. So you put that drawing in first of all, and then you have it on the laser cutting software. So some laser cutters have different software. It's then converted into a CNC program, and that is basically, that's called G code, and that code basically is what speaks to the laser cutter. Because obviously the laser cutter doesn't understand if you just got your drawing. You need to have that in code that the laser cutter can understand, and that's what makes it work. So that's laser cutting. So the next one is routing. So this can be done in 2D or 3D depending on how many axes it can move. So we do have a CNC router in college, quite a big bed. So it looks fairly similar to the diagram that we've got here. So typically it's done the same way that you would do the laser cutter, in that you would have your drawing. So whether it's on 2D design, if you're just going to do a standard 2D thing where you're sort of going to engrave information onto something, or if you're going to do it in 3D, you'd have to use 3D software like Fusion 360. And how it will work is you have your block of material. So typically it could be anything. It could be styrofoam, MDF, natural timbers. Depending on the bits that you get, you could do metal as well. You just have to get a high speed or a tougher cutter, and it will waste away material. So you start with a big block of material and it will remove the material away. Now, because it's all self-contained, you don't necessarily need an extraction unit, because then you can just open it up and vacuum it all out yourself. But it's quite good to have vacuum extraction in it. But it's all encased, and it works the same way that a normal router will work. You have your cutter that spins around, and it just follows the same way that the laser cutter does. You have your G code, and it follows the drawing, follows all that programming to remove your excess material. So milling now works pretty similar to the way a CNC router works, but it will also let you do, typically it's used for metals. It can do some other materials as well, but sometimes if you were to say use timbers, what can sometimes happen is dust and shavings can get inside the machine, and it sort of stops it working too well. Really fancy ones will have multiple heads, so you can have different sized cutters at different stages, so it will rotate around. So normally they're encased fully, because it can be quite, not dangerous, but there's a lot of moving parts and it can get quite hot. So what they have is they have coolants and lubricants that they will constantly flood the area with to stop it from getting too hot, stop from damaging the tools or the material. And it will let it go in loads of different directions. So you've got your X, Y, so that goes left, right, backwards and forwards, and then Z, which is your up and down. So it will let you go in lots of different directions. There is manual milling machine, so we do have a milling machine in our workshop as well. We do not have a CNC one though, as much as I would like to have one, but it's a very, very cool piece of engineering kit. Now turning, again, is a one that you can get a CNC one and you can do manually as well. So that includes, it involves using a lathe, typically used for like metal bars or plastic rods. So what will happen is same thing, you'll have it programmed, you put your material in and it will spin around and it will let you reduce the thicknesses of bars, or to cut like threads for screws, or if you're going to do something where it's got to have decorative like waves on it, anything like that. But the benefit is because it's done remotely and because it's done automatically, it removes the risk of human error. So that's why, for example, if you take the wood turning lathe, it's harder to be more accurate because you're in charge of the cutter, because you're holding the gouge or the scraper. There's always that possibility of a mistake, whereas if you are doing CNC turning, it's going to get it right. So next you've got your plotter cutter, also known as a vinyl cutter. So typically this will use cut things like card, vinyl, and it works the same way. You'll have, typically on 2D design, you'll have your vectorized image, and what happens is there's a little blade that goes left to right, and there's feeders that will push the material forwards and backwards until you cut out your material. Used really extensively for things like car graphics and things like that. So next you've got virtual modeling. So this is basically where you companies will test products before they actually make them, so they've not wasted time or money. So that might be if they have a component. So typically if you see like F1 has just started up, and I'm a big F1 fan, I love seeing how the technology all develops from that. So what they'll do, rather than make all the parts for a car and just test it and see how it goes on the actual car, they will run simulations. They have their virtual model of the car on the software. They'll try a new component for the car, they'll design it, they'll put it on, and then they'll run testing on it to see if it will work. What this does, it also lets you plan out everything first before you invest in anything, so you know if it's going to be worth your time or not. So next we've got a few sort of ways of analysing what you've done. So finite element analysis. So this is done in CAD software, so things like Fusion 360 will let you do it as well. So this will let the software carry out stress analysis of something. So typically things like architectural structures, bridges, buildings, things like that, anything that takes stress. So what you can do is you can do your design and then you can run the simulation, and what you see, so you see where it's got blue, green and red. So typically red is where the most stress is being placed on the product or the thing, and blue is none, it's absolutely fine. So it lets you test out your design to see if it's structurally strong or not. So then computational fluid dynamics. So this is where, in a similar way to finite element analysis, you can test in your CAD package. But this time what you're doing is you're testing for aerodynamics. Now I used the example of F1 on the previous slide, and the same thing again is that you can take your components, put them on, in this example, the F1 car, and you can test to see how it's going to do in an aerodynamic situation. And then next one is rapid prototyping. So this is where you have your CAD software, you have done your drawing, and then typically normally done with 3D printing, and you can make rough models of your thing really quickly. So it lets you model it. So we've got a 3D printer, we just want to get an idea of the overall shape and size or ergonomics or something, so we'll do it on CAD, set it up to the 3D printer. That'll take a couple of hours to make. The idea being that you can produce models quickly and easily that you can take to a client, get them to feel it, see what they reckon, and it's a lot easier and faster than having to have a specialist go into a workshop and carve something or make something by hand. And then we've now got fused deposition modeling, which is the fancy way of saying 3D printing. That's the technical name. So there's two different ways 3D printers work. So we're going to focus on just one of them today. The one we're going to work on is fused deposition modeling. The other one is to do with resin 3D printing. So these essentially work in the exact opposite way as routing. So when we talked about CNC routing, you start with a big chunk of material and the cutter removes the excess material, and then what you're left with is what your design is. Whereas what happens with 3D printing is you've got your material, your filament, and you can get all different colours, you can get all fancy ones, glow in the dark ones, whatever it may be, and you've got your bed and you've got the nozzle, and what will happen is it will build up layer by layer. So I don't know if anyone's ever seen videos of 3D printers working before. It starts from the bottom and it will slowly make a few passes over and over again. It will just slowly start building up as the filament is heated and softened a little bit by the nozzle, so there's heaters in there that soften it all up, so it comes out, and then as it comes out it cools and hardens, and then it slowly builds up. Now, because of development, you are starting to see 3D printers that start to work in things like metal as well. Now, they are more expensive, and you can get industry standard ones that are quite big, so they will fit in the workshop, but only just. But it's like with, if you think about like laser cutters and how big they were originally and slowly as they developed. So 3D printing now is developing so quickly, and you can print in so many more materials that year by year they're getting smaller, they're getting more compact, they are getting cheaper. So now we're looking at electronic point of sale. So this is a system for how shops capture data when you go and buy something. Let's take like Tesco's, for example. So everything there has got a barcode on it. So the barcode is what's scanned. So when you go and pay for it, the barcode is scanned. Now what they are actually scanning is the light is reflecting off the white part. I know in this diagram it's looking at the black part, but actually what is happening is the light is reflecting off the white part and bouncing back to the machine. Now what this does is, first of all, obviously it tells the till, right, that is a tin of baked beans and it costs 89p or whatever it is. What it is actually doing as well, it's used for stock control levels. So say they have 100 tins of baked beans and you buy 3 of them. What it's just said, so you just scanned it through the system, it's now said to the machine, right, we've now got 97. So what can happen is when their stock gets to below, say, 20, automatically they'll order a new set. So that's what makes them make sure they never run out of stock. That information that they've used is also then used for marketing. That's why if you've got things like Nectar cards or club cards and they know what you've been buying, that's why they sort of target you and say, right, here you go, here's a voucher for 10% off toothpaste or whatever it is that you've used. And the last little bit we're going to go over is production planning and control networking. So this is basically how companies set up so they can be as productive as possible. So like the whole supply chain, from where they get their materials all the way through to how they make their products. So there is something called just in time. So if you've done business studies, you'll have heard this before. So just in time works in the concept that you don't have stock ready, so you don't have things pre-made ready to go when a customer wants it. What you do is, as soon as a customer places an order, everything starts off. So your supply chain works is you then place an order for your materials, that is all delivered within a certain time frame, then it is all produced, and then it's made just in time for the consumer to have it. The benefit of that being that you don't have to spend money on things like warehouses to store your materials. The drawback being that if something in that supply chain fails, then what will happen is that you won't be able to produce your product in time for your consumer, so you might end up with an unhappy customer. So next you got our master production schedule. So that's basically a plan that determines how many products we made in a given period. So this is done using software that basically talks to the business and lets them know how much you need and when you're going to need it. So what this does, it just stops you from over ordering and over producing them. Because otherwise what will happen if you have too much stock, certain things, they just sort of go out and they're not needed anymore. So if you think things like football shirts or certain computer games, because they come out of fashion or they stop being popular after the season is over or when the next one is over, if you make too many of them and they end up just sitting in a warehouse, that's lost money. So what you also have is something called the Kanban system, which is what to make sure that materials arrive correctly and at the same point, which is basically just a way of organizing what you're doing. So you have MPS software that controls the equipment for things like robots, and it's automatically reconfigured to make certain models and cars, so you know exactly what you're going to do. So 8 questions there. Can you pause the video, have a go at answering them, and then unpause the video and I'll put the answers on for you. Okay, so that is a quick tour of CAD and CAM for first year content. If you've got any questions, please feel free to send me an email. My email is on the SharePoint. and I will either one, try and respond by email, or two, if it's worth doing a video for it, I'll do that instead.